All right, so let's look at this question, which is talking about thermal expansion. So the question reads, the coefficient of linear expansion of a metal sphere is 9 times 10 to the power minus 6 per degree Celsius. The internal diameter of the metal sphere at 20 degrees Celsius is 4.2 centimeters. If the final diameter is 4.8 centimeters, what is the final temperature? If the final diameter is 4.8 centimeters, what is the final diameter? All right, so we know to say when we are talking about expansion in diameter, it is the same as linear expansion. So we'll introduce the formula for linear expansion to say change in length is equal to alpha, which is the coefficient of linear expansion, multiplied by initial length, multiplied by the change in temperature, like that. So since they're asking us to find the final temperature, we can use this equation that we've written here to find the change in temperature, delta T. Then we'll add this change in temperature that we're going to calculate to the 20 degrees Celsius, such that it's going to give us the final temperature. But how are we going to do that first? Let's change this form of the equation into the equation we're going to use to find the change in temperature using the diameters that we've been given here. So we're going to say we have initial diameter, which is 4.2. We have initial temperature, which is 20 degrees Celsius. We have final diameter, which is 4.8. Then we have the coefficient of linear expansion, which is 9 times 10 to the power minus 6. So the first thing we can do is subtract the final diameter, or subtract the initial diameter from the final diameter, so that we find the change in diameter. And if we find that change in diameter, it's the one that we're going to plug here. That's why I'm saying if we write this equation, we're going to get change in diameter will be equal to alpha multiplied by initial diameter multiplied by change in temperature, like that. So if I say final diameter, T final minus D initial, I'm going to get change in diameter, which will be equal to 4.8 minus 4.2, giving me 0.6 centimeters. That is the change in diameter, and that is the one that we're going to plug here. So let's plug in everything that we have to find the change in temperature. So I'll say my change in D, which is 0.6, will be equal to alpha, which is 9 times 10 to the power minus 6 multiplied by the initial diameter, which is 4.2 multiplied by the change in temperature, which we'll just call delta T for change in temperature. So since we are looking for change in temperature, we can now make it the subject of the formula. So we're going to get delta T will be equal to 0.6 divided by 9 times 10 to the power minus 6 multiplied by 4.2, like that. So this is going to give us a change in diameter, or a change in temperature, sorry. A change in temperature, which will be equal to, let's plug it into our calculator. Let's plug it into our calculator. 0.6 divided by 9 times 10 to the power minus 6 multiplied by 4.2. Okay, so this is giving me 1.59. 1.59 times 10 to the power 4 degrees Celsius. 1.59 times 10 to the power 4 degrees Celsius. So this is the change in temperature. This is a very huge number. This was the increase in temperature, which means this is the final temperature minus the initial temperature. It should give us this guy. So we can now use this guy to find the final temperature. So we're going to say change in temperature is equal to T final minus T initial. Since we have the change in temperature and we also have the T initial, we're going to say T final will be equal to the change in temperature or the initial temperature itself, just say 1.59 times 10 to the power 4 plus the initial temperature, which is 20 degrees Celsius. And this is going to give us the final temperature, which is just add the two. Okay, so this is giving us 15 1589.3 1589.3 1589.3 degrees Celsius 1589.3 degrees Celsius. That is the final temperature 1589.3 degrees Celsius. So this one, instead of writing it in scientific notation, if you want, you can just add it there, or you can write this answer as 1587.3 degrees Celsius, like that, so that we are accurate when it comes to the final answer, because like that it was already rounded off and it was going to become a bit difficult to add 20, which was just a small number, and it would have shown any significant difference if we 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 simplify it in advance. Yes, so this is the final answer. 1589.3 degrees Celsius is the final temperature. And that is all on this particular question.